All right, guys, here we go. Can I get a thumbs up at home that you hear me and see the board okay? Awesome. All right, let's do this, guys. We are still in section 5, solving these higher degree polynomial equations. We're going to be in here all week. Tomorrow, I don't know what I'm going to do tomorrow, whether I give you some type of small review, but Friday will be our quiz on solving these. And then next week, we'll head to graphing them. Today's problems. These ones I'm hoping, should feel like, they should feel a little bit more relaxed, maybe a little bit more like, do I dare say the word normal? They're not quadratics by any means. These are not degree 2 equations, but guys, they're gonna feel like you're factoring a quadratic. These are gonna feel like we're going back to the this and this gotta multiply to that, they gotta get me my rainbows. So it kind of should feel better in the sense that this might feel like a little bit more normal factoring. We're not gonna have to group anything or worry about that, all right? So look here, I put the directions up top still, but in example 1, find all the x-intercepts, right? Okay, if we're going to find the x-intercepts of this polynomial function, we got to find the roots, we got to find the zeros, we got to find the answers. So let's set it equal to 0, and let's start solving. It is, did I get the notes out? Yeah. It is a degree 4 polynomial, right? So a degree 4 at the end should have 4 roots or zeros or answers. But if any of those are imaginary, we're not going to include them as an x-intercept. All right, so guys, if you go through all the motions like we've been doing, I've looked for a GCF, but they actually don't have one. There's no number and no variable that they all share. So there's no GCF. Then you could be like, well, it's degree 4 still. Should I try grouping? You can't even group it because there's not enough terms. If you're going to group, you have to group 2 and then group 2. But there's no 4th term. So you can't even use grouping. So now it's kind of like, well, how do you expect me to factor that degree 4 from scratch? But guys, pay attention. These are special degree 4s because if you notice, it's got an x to the 4th, then it has an x squared, which this degree is half of his degree, that's important, and then this one doesn't even have a variable. So guys, if you think about a normal quadratic, don't write this down, but watch. If this was x squared minus 11x and then plus 24, like a normal quadratic, right? Well, did you guys ever notice that the middle degree is half of that one? It's 1, which is half of 2, and then the last number doesn't even have a variable. So when we went through the factoring motions, again, don't write this down, we would just say, all right, whatever I put here and here has to multiply to x squared. But remember, whatever you put here and here, it doesn't just have to get you x squared, it also has to allow your rainbows to get an x term. So that's why we use xx, because then it allows you to get x's as your middle term from your rainbows. So guys, can you think about it in this sense? What could you put here and here that would allow you to get an x to the 4th, and then your rainbows could add up to an x squared terms? Anybody know what you could put in the first 2 spots to get an x to the 4th? And then what would allow your rainbows to get an x squared? Not an xx, but an x. Anybody know? An x? I thought you said it, sorry. What about an x squared and an x squared? What are they going to multiply to? X to the 4th. What are your rainbows going to add up to? Some type of x squared. So we're going to factor it just like a quadratic, but instead of needing xx, you're going to need x squared, and then everything else in the factoring process stays exactly the same. So that's the only difference. We're going to need x squareds in the beginning instead of just x's. All right, so I'm going to move right up. All right, so let's do this. So let's factor this. So I'm going to give myself an x squared and an x squared to get me that x to the 4th and still allow myself to get those x squareds from my rainbows. All right, now I know from normal factoring procedure, I know whatever numbers I put here have to multiply to 24, and then my rainbows have to add up to negative 11x squared. Anybody know what numbers will do this?
Negative 8 and negative 3.
Perfect. In any order, a negative 8 and a negative 3, and you did it. So it factors very much so like a quadratic. Instead of needing x's though, you need x squares. And you're done. And then everything else stays the same in the factoring process. But now if you notice, your factors aren't linear factors anymore. They're not x minus 8, they're not x minus 3, they're not these little linear degree 1 factors. Now you have quadratic factors, which is fine. We've been solving them all along, right? We can just set this factor equal to 0, and we'll solve this little tiny quadratic equation. All right, remember, since this is a quadratic equation, you should get 2 answers from him. So let's add 8. Let's take the square root of both sides. All right, the square and the square cancel, I get x, but remember, when you take the square root of a square, it creates 2 answers, the positive and the negative version. All right, guys, we're going to bring back some memories here. The square root of 8. You can't take the square root of 8 and get a whole number, but the square root of 8 needs to be simplified. It is not a simplified radical. Does anybody know what perfect square divides evenly into 8? What number can you take a square root of that does divide into 8? 4. So we're going to break it up into the square root of 4 times the square root of, well, 4 times what got you 8? 2. And now, what is the square root of 4? 2 times the square root of 2 stays. So remember when we were simplifying square roots? So you don't want to leave a radical that is not simplified. So now your answer is going to be plus or minus 2 root 2. And you got 2 answers out of the 4 that we're looking for. And guys, those are real numbers. I mean, they're decimals, they're ugly numbers, but they're still real. All right, now we'll come over here, we'll set this factor equal to 0. And again, it leaves you with another tiny quadratic equation to solve, so we should get 2 more answers from this. Let's add our 3. Take the square root of both sides. The square and the square cancel, leaves me with x. Taking the square root of a square gets me 2 answers, plus or minus. Can you take the square root of 3? No. Does the square root of 3 simplify? Nope. So we are home free. We just leave it as the square root of 3. Which, guys, it's 1.7-ish. So if you ever had to graph it, you would just use 1.7. But when you're giving it as an answer, leave it in its exact answer form, which is the square root. All right, so now we got 1, 2, 3, 4 of our 4 answers. Now let's get our x-intercepts. The only ones we would list as x-intercepts are any real numbers. But guys, all of these were real. Nothing was imaginary, so all 4 of them come along. So I'm going to ask you guys to leave it with the plus or minus sign. So we're going to say plus or minus 2 root 2, comma, plus or minus root 3. Again, when you write them individually, one answer is 2 root 2. One answer is negative 2 times root 2. One answer is the positive square root of 3. And one answer is the negative square root of 3. That's all 4 of your answers as separate. However, I had to make tonight's homework problems. Like I literally had to create the problem on Delta Math. So they only gave me one choice to write the answers, and it left it like this. So please don't split them up and write them individually tonight. Please leave them as the plus or minus 2 root 2 and the plus or minus root 3. I'm not 100% sure if it's going to mark you wrong if you write them separately. So I just please ask you to just keep them together and write them with the plus or minus sign. And it'll be right under your answer box. There'll be a plus or minus sign and a square root. All right? Because again, I had to make these problems, and I don't know if it's going to let you do that and still get right. Now, I gave you 3 tries on each problem, so even if you wrote this and it marked you wrong, you'd still have 2 more tries to type that before you actually had to redo the problem. All right, let's go to the next example. All right, it's going to bring back some memories too. All right, guys, same thing. Find all the x-intercepts. We got to find the roots. We got to find the zeros. So let's set this equal to 0 and start solving. This is a degree 4, so it should have 4 roots, 4 zeros at the end. But if any of those 4 answers are imaginary, we don't include them. All right, it's kind of like, whoa, wait, what's going on here? X to the 4th minus 25. There's no GCF, and again, you can't group it. But guys, if you pictured this as a quadratic, if this was x squared minus 25, does anybody remember how we factored this? It's the difference of 2 squares. You'd be looking for what times what got you x squared, xx, and you'd be looking for 2 numbers that multiply to negative 25, but then your rainbows would add up to the 0 x's in the middle. Does anybody remember? The difference of 2 squares, guys, they always factored to matching factors, except one was a positive and one was a negative. So do you know what numbers we need to make this happen? Plus 5 and minus 5. Difference of 2 squares always factored to matching factors, except one was plus and one was minus. So guys, if you look at this one, does anybody know what you could put here and here to get x to the 4th? X squared, x squared. And then what numbers do you need to multiply to that negative 25? And then your rainbows have to add up to those no x squareds in the middle. A plus 5 and a minus 5. So it still factors like the difference of two squares. You're left with these matching factors. One's positive and one's negative. Is everybody okay with that? Nice and easy? All right, now we just set our factors equal to 0 and solve. So let's set this one equal to 0. And again, I'm solving a quadratic, so I should get two answers from this. Minus 5, that is not good, but we're going to keep going. I'm going to take the square root of both sides, which means, yes, I'm taking the square root of a negative number. Not good. So then you get x equals, I'll get two answers, plus or minus. Do you guys remember how we do this again? The square root of negative 5. First, we factor out the square root of negative 1, and then we make it a positive 5. So it's now the square root of negative 1 times the square root of positive 5. And who's the square root of negative 1? I. So it's I times the square root of 5, because 5 is a simplified radical. So that's what you would put here, plus or minus I times the square root of 5. So there's 2 out of those 4 answers. And again, if you're sitting here saying, well, Hardy, I knew that was imaginary, so I know it's not going to be an x-intercept, so I didn't even solve it. I just want you guys to realize that in the future, if the directions say find the zeros, then you are going to have to solve this and include this as a 0, because it is a 0. So you should continue solving just to get the practice in. All right, let's set this factor equal to 0. We're going to add 5, so this one's much better. We get x squared equals 5. Square root both sides, and you get x equals two answers, plus or minus. The square root of 5 cannot be simplified, and you can't take it. So it's just the square root of 5. And there are your 1, 2, 3, 4 root zeros or answers. Now let's get our x-intercepts. The x-intercepts, guys, are only going to be the real numbers. So since they're imaginary, those are the only two x-intercepts, plus or minus root 5. Positive root 5, which is like, I don't know, like 2.4 or something, maybe 2.3, and then negative 2.3, the negative square root of 5. But we leave them in their exact form. And then again, please leave them as the plus or minus. Don't split them. I don't know if you'll get marked wrong. And you're done. So do you guys see how it should feel like a quadratic, even though it's not a quadratic? We're still factoring in that same type of motion. All right, I'm going to ask you guys to try number 3. I'll give you a head start, and then I'll start slowly doing mine, and we'll see if we're on the same page. So you guys try 3. It should feel like a quadratic. Go ahead, Josh. Yeah. All right, so at home, try to do number 3. That's what I got mine to factor to. I factored it just like a quadratic, except I need an x squared to get me my x to the fourth, and then it would be my 6 and negative 3 multiplied to negative 18, and then my rainbows will add up to positive 3x squared. Okay? Set my factors equal to 0. That's not good, but I'm going to keep going anyway just to get the practice. X will equal plus or minus. I'll get 2 answers from this degree 2. The square root of negative 6. The first thing I would do is rewrite that by pulling out that factor of negative 1. And then the factor of negative 1, that's our I. And then the square root of 6 can't be simplified. So plus or minus I root 6. Those are 2 of my 4 roots or zeros. Take this factor, set them equal to 0. I'm going to add 3, so that's much better. Take the square root of both sides. X will be, I'll get 2 answers, plus or minus. The square root of 3, can't simplify it, can't take it. It stays. It's like 1.7 and negative 1.7, but we want exact answers, not these irrational, never-ending, non-repeating decimals. All right, so those are my 4 answers. Now I need my x-intercepts, so I just keep the real ones, which are just plus and minus root 3. So all you'd have to write is plus or minus root 3. Please don't split them, write them like that. Did you get it? Are you guys okay? Awesome. All right, let's go to example 4. Guys at home, how we doing? Everybody all right? Hanging in? Thumbs up? All right, keep going. You're doing great. All right, look at number 4. Right away, it should be like, wait a minute, Hardy, this don't look like the ones you've been telling us, factor like quadratics. This is a degree 5. He's got half of his. He's got an x. That's okay, because what do we always look for first? We always look for GCFs. So when we go to solve this one, we're going to set it equal to 0. Yes, it's a degree 5, so technically I should have 5 roots or zeros this time. All right? Look for a GCF. What do they have in common? They all have an x, and since it leads with a negative, take out the negative. So let's all take a negative xf. That'll leave us with x to the fourth minus 4x squared, and then minus 45. Now you look to factor what's left again, and now that looks like one of those degree 4s that factors like a quadratic. So you guys finish this one. See what you get. I had it in here. Right? See if you can factor that. It should feel like you're factoring a quadratic now, but it's a degree 4. All right, I need x squareds now to get me that x to the fourth and still get me those x squareds in the middle. Now I'm looking for numbers that multiply to negative 45, and my rainbows are going to add up to those negative 4s. You need a negative 9 and a positive 5 if you did it correctly. And then always don't forget to bring that GCF down because he is one of your factors, and you're going to need to get an answer from him in the end. All right, now when you go from here, 2 things could happen. Some of you are going to go right to setting your factors equal to 0, and you are 100% okay to do that. But did anybody recognize who x squared minus 9 is? X squared minus 9 is the difference of 2 squares. So he actually will factor again, and you could factor him into the x plus 3 and the x minus 3. So then you'd have negative x, x plus 3, x minus 3, x squared plus 5. You wouldn't even have this anymore because he factored again. And you would now set all your factors equal to 0. And when you set this one equal to 0, you would get negative 3. And when you set this one equal to 0, you would get 3. And then you'd get an answer from him and an answer from that, or 2 answers. So if you wanted to factor this again, have at it. You're going to get your answers from it. But if you're just in that solving mode, it's okay to not factor this again and just set it equal to 0 and start solving. You're going to get these answers when you set this equal to 0 and solve anyway. So it's your choice whether you want to factor this again or whether you want to just set this factor equal to 0 and solve. All right, let's say you didn't factor again. You set negative x equal to 0, divide by negative 1, and you get x equals 0. So there's 1 out of the 5 answers I should have. Take x squared minus 9, set it equal to 0, add 9, square root both sides, x will equal, I get 2 answers, that's the important part, you gotta remember you get 2 answers, plus or minus, who's the square root of 9? It's 3. So you get plus or minus 3 just by setting this equal to 0 and solving. Just like you would have gotten 3 and negative 3 if you factored it and set those factors equal to 0. So it's your decision. Do you want to factor it again or you just want to solve it? It doesn't matter to me. All right, and then we set this one equal to 0, which doesn't look like it's going to help us, but I'm going to solve it anyway. I minus the 5. That's not good. I'm going to square root both sides. So then x will equal plus or minus the square root of negative 5. First, I would pull out that factor of negative 1. And now it becomes I root 5, which is obviously imaginary, but it's still a root or a 0. All right, so now I get 1, 2, 3, 4, 5 answers to my degree 5. So now when we go to list our x-intercepts, we just list the real numbers, which are 0 and plus or minus 3. And you're good to go. How do we feel, okay? All right, I'm going to ask you guys to try the last one. The last one actually has a GCF, and then it is actually a quadratic that you are left with. So try the last one. I'll do it up here, you do it down there. I guess I could leave that. I should have left it. And again, when you do this one, when you take out the GCF, you're left with x squared minus 64. So either you can set that equal to 0 and get your answers, or did anybody recognize that that is the difference of 2 squares? And he could have factored to x plus 8, x minus 8. And then you could have had this, this, and this to set equal to 0 and get your answers. It's up to you whether you choose to factor that again or just go right to the solving. All right, so I set this equal to 0. I'm going to think of it as x times x. So then I get x equals 0, and I get x equals 0. Or you get plus or minus 0. At the end of the day, though, you get 2 answers from this, but it's really just x equals 0 that you get, but you do get it twice. All right, and then we can set this one equal to 0, add it, square root it, and x equals, as long as you remember, you're going to get 2 answers, plus or minus. The square root of 64 is 8, just like you would have gotten had you factored and set them equal to 0. All right, so our x-intercepts are just 0, even though I got them twice, you only got to list it once, and then plus or minus 8. All right, how do you guys feel? Everybody okay? Hopefully it kind of feels like we're going back to normal a little bit. At home, are we okay? Yes? All right. So guys, I did make a homework for this. It's 6 questions on Delta Math. It is due tomorrow night at 11:45. But don't forget, Monday's homework, those 10 questions, are finally due tonight. A lot of you already have it done, but if you don't, that homework is due tonight. All right, let me double check your attendance, and then you guys are good to go.